Complex numbers are the set of all numbers in the form of a plus bi, such that a is a real number and bi is an imaginary number. Real numbers are positive numbers, negative numbers, whole numbers, or decimal numbers. Whereas imaginary number is I, which is equal to square root of minus 1, and I square, which is equal to minus 1. Example for imaginary numbers are square root of negative 64, which is equal to square root of negative 1 times 64, which is equal to square root of negative 1 times square root of 64. Square root of 64 is 8 and square root of minus 1 is I. Hence the answer is 8i. Another example, 3i the whole square is equal to 3 square times I square. 3 square is 9 and I square is minus 1. Hence the answer is minus 9. Complex numbers are those numbers in the form of a plus bi. Example for complex numbers are minus 2 plus 4i, 7 minus 3i, 12 plus 6i. Now adding complex numbers. A plus bi plus c plus di. We have to add the like terms together. Group the real numbers and imaginary numbers together. In our example, 3 and 4 are real numbers, 6i and minus 2i are imaginary numbers. So when we group 3 and 4 together, 3 plus 4, which is equal to 7, and then we group 6i and minus 2i together, which is 6i minus 2i, which is equal to 4i. Hence the answer is 7 plus 4i. Let's see another example. 5 plus 2 square root of minus 16 plus 2 plus 3 square root of minus 9. First you have to rewrite as complex numbers. Square root of minus 16 is square root of minus 1 times square root of 16, which is equal to square root of minus 1 is I and square root of 16 is 4, which is equal to 4i. And square root of minus 9 is square root of minus 1 times square root of 9. Square root of minus 1 is I and square root of 9 is 3. So the answer is 3i. Now rewrite the question as complex numbers. So we can rewrite it as 5 plus 2 times 4i plus 2 plus 3 times 3i. 5 and 2 can be grouped together and 2 times 4i and 3 times 3i can be grouped together. 2 times 4i is 8i, 3 times 3i is 9i. So 5 plus 2 is 7 plus 8i plus 9i, which gives us 17i. Hence the final answer is 7 plus 17i. Next topic is subtracting the complex numbers. While we are subtracting, we are again using the same rule as adding the numbers. We are grouping the real numbers together and imaginary numbers together. See an example. 9 minus 6i minus 12 plus 2i. 9 minus 12 together and minus 6i minus 2i together. 9 minus 12 is minus 3, minus 6i minus 2i is minus 8i. Hence the answer is minus 3 minus 8i. Let's see another question. 3 minus 2 root minus 18 minus 2 plus 3 root minus 8. So first thing we have to do is rewrite the question in the form of complex numbers. Root minus 18 is equal to square root of minus 1 times square root of 18. Square root of minus 1 is I and square root of 18 is square root of 9 times square root of 2. Square root of 9 is again 3. So the answer is 3I square root 2. Square root of minus 8 is equal to square root of minus 1 times square root of 8. Square root of minus 8 is equal to 2I square root of 2. Hence we can write the question in the form of 3 minus 2, 3I square root minus 2 plus 3, 2I square root. 3 minus, when we open the bracket, 3 minus 6I square root of 2 minus 2 plus 6I square root of 2. 3 minus 2 together minus 6I square root of 2 minus 6I square root of 2 together. 3 minus 2, 1. Minus 6I square root of 2 minus 6I square root of 2 will be equal to minus 12I square root of 2. Next is multiplying complex numbers. A plus bi times c plus di. For multiplication, we use the FOIL method to multiply, which is first outside, inside, last. Multiply the first terms in either brackets, which is a times c, plus multiply the outside terms of both the brackets, which is a times di, plus multiply the inside terms of both the brackets, which is bi times c, plus multiply the last terms in both the brackets, which is bi times di, which is bdi square. I square is square root of minus 1 the whole square, which is equal to minus 1. So in this example, minus 8 plus 10i times 3 plus 8i, multiply minus 8 times 3 plus minus 8 times 8i plus 10i times 3 plus 10i times 8i. The answer will be minus 24 minus 64i plus 30i as 80i square. Since I square is minus 1, this will be equal to minus 80. Hence the final answer will be minus 104 minus 34i. Example number 2. 8 plus 7i times 4 plus 5i. Again use FOIL method. 8 times 4 plus 8 times 5i plus 7i times 4 plus 7i times 5i gives us the answer 32 plus 40i plus 28i plus 35i square. I square is minus 1, hence 35 times minus 1 gives us minus 35. So the final answer is minus 3. So the final answer is minus 3 plus 68i. Next is dividing complex numbers. A plus bi divided by c plus di. For dividing complex numbers, we can use complex conjugates. Complex conjugates are found by changing the sign of the complex number. A plus bi complex conjugate will be a minus bi. A minus bi complex conjugate will be a plus bi. A plus bi times a minus bi is equal to a square minus abi plus abi minus b square I square. The like terms abi and minus abi cancels each other. I square is minus 1. Hence, the final answer will be a square plus b square. The same is applicable in the case of a minus bi times a plus bi, which will also give the final answer as a square plus b square. So by multiplying the denominator by its complex conjugate, we will get minus 8 plus 6i by 8 minus 5i times 8 plus 5i divided by 8 plus 5i. So minus 8 plus 6i times 8 plus 5i gives minus 64 minus 40i plus 48i plus 30i square divided by 8 minus 5i times 8 plus 5i. The answer will be a square plus b square, which is 8 square plus 5 square, which is 64 plus 25. Hence, the final answer will be minus 94 plus 8i the whole divided by 89. Let's look another example. 10 plus 4i by minus 4 minus 3i. The complex conjugate of the denominator is minus 4 plus 3i. Multiply numerator and denominator with the complex conjugate of the denominator. When we open the bracket, we will get 10 plus 4i times minus 4 plus 3i. We can use first in out. So the final answer will be minus 40 plus 30i minus 16i plus 12i square by 16 plus 9.